Hi, welcome to this episode of Lightboard Lessons, and today we're going to talk about QUIC, and that is the QUIC UDP Internet Connection protocol. It was developed by Google, and it's in the process now of being developed by the IETF, but we'll kind of go through the basics of the protocol and why it matters. So if you recall when we talked about HTTP2, we had a protocol stack, and so you have your IP layer here, and this is IP. Okay, and then on top of IP, you have TCP, and then optionally in HTTP2 TLS. However, that is a de facto standard because all the browsers, all the major browsers require it. But the protocol itself, HTTP2, does not require TLS. But this is the stack for HTTP2 traffic. And if you recall from the video that we did about HTTP2, one of the big fixes that HTTP2 has over version 1 is the application head-of-line blocking issue, which is great at the application level. However, that doesn't solve TCP's head-of-line blocking problem. And so what QUIC, one of the issues that QUIC seeks to solve is that. And so QUIC, by contrast, is if we kind of go halfway up like TCP, QUIC runs on UDP. And then we'll go up through crypto and halfway up through HTTP2, and we'll say this whole thing is QUIC, and then right on top of that you have the second part, which is the application-specific parts of HTTP2. And so QUIC is kind of steals all the good things from TCP, TLS, and the control aspects of HTTP2 and the streaming aspects, and it becomes its own protocol. And so this rides on top of UDP. And one of the things that is so helpful about this is TCP and UDP primarily live in kernel space. And the key part of that is it's really hard to change that. It's really hard to make fundamental changes to the protocols, and it takes years at times. And so what QUIC does is QUIC is implemented in user space. And QUIC, being developed by Google, well, Google owns a lot of the client side of a connection in their Chrome browser. And then, of course, on the server side, Google has a lot of services like Gmail and, of course, their search engine at google.com and so on. They have a lot of services here. And so because this is implemented in user space, they can do a lot of experimentation between a large number of clients and servers across the world. So if you're looking at real world testing, you have every possible situation you could think of as far as distance, loss, all the things that you would want to test in connections. You have that in a real world scenario when you control both of those things. And so they went through that. In fact, on Chrome, you can enable QUIC in your browser utilities. And so, when we talk about connections, if you look at this stack, you're looking at, here at the TCP level, you're looking at the three-way handshake, so you're like 1.5, but effectively 2 round trips here. With TLS setup, if it's an initial setup versus a renegotiation, you're looking at upwards of 4 round trips for TLS. So you're looking at 6 round trips before you get to running your application. With QUIC, you're looking at 1 to 2, depending on if it's a known server or not. So you've eliminated a lot of round trips. So, with TCP, the farther and farther you get away with milliseconds, the longer it takes to complete connections. And when you have to constantly set up connections, that's a big deal. And being 300 milliseconds away versus being 8 milliseconds away, very impactful. But with UDP doesn't care. It just send the traffic and we're done. And so you build some of the things you need on top of UDP, and some of the design requirements that the QUIC team went through is they wanted to take the best of what TCP had to offer. So you've got improved loss control and congestion feedback in there. And incidentally, TLS 1.3 will be adopted as part of the crypto part. So it's handling flow control, it's handling the crypto, and then it's handling the HTTP parts of that as well. One of the other cool things before we wrap this up is when I mentioned the head of line blocking problem that was in TCP, because everything is streamed with QUIC at both the application and the transport layer, if you lose packets between the client and the server, then whatever that particular stream that lost a packet, that's the only thing that gets blocked, because UDP doesn't care about order. TCP, you have to have the packets in order, but UDP doesn't care about that. So by implementing QUIC, you get stream impaction instead of entire connection impaction, which is pretty cool. And then the other thing that's kind of interesting about QUIC is that if you look at connection identity with TCP-based things, you have your client side IP port, your server side IP port, and so you build a connection ID out of that information. With QUIC, it's got its own connection UUID, independent of IPs and ports. And so that's interesting, because now you can switch from Wi-Fi to your cell to your wired connection, and you're not gonna lose that information. The connection can still live through that. And so there's a lot more we could talk about with QUIC, but that's kind of an overview. It's pretty cool. You can definitely enable it in your browser, and there's some server tools that you can build to test with that. But if you go to the Google services, you'll be able to test and play around and look at the analytics from a client perspective in your browser. So thanks for joining me. If you like this video, click subscribe, and we'll see you out there in the community.